Here's a number that should terrify every AI executive: 95%. That's the failure rate of generative AI pilot programs in 2026. Despite hundreds of billions in investment, despite all the breathless headlines about artificial general intelligence, 95% of real-world AI projects are delivering no measurable business value. And that's just the beginning of what might be the most important story in tech that nobody's talking about. Welcome to Mindcast, the show where we dive deep into the technologies reshaping our world. I'm Will, and today we're exploring something I'm calling the post-hype paradigm, the dramatic reality check that hit the AI industry in 2026. If you've been following AI news, you might have noticed something strange this year. The confident predictions about AGI arriving by 2030 have gone quiet. The $1 trillion valuations are being questioned, and industry leaders are talking less about building superintelligence and more about making AI actually work. Today's episode is based on groundbreaking new research that reveals exactly what's happening behind the scenes. We'll explore 3 seismic shifts: an economic awakening that's reshaping Silicon Valley, a legal earthquake that's rewriting the rules of data, and a technical pivot that's more revolutionary than the transformer architecture itself. By the end of this episode, you'll understand why 2026 isn't the year AI failed, it's the year AI finally grew up. Let's dive in. Let's start with the money, because nothing cuts through hype quite like a corporate balance sheet under pressure. Here's the most sobering statistic I've encountered this year. While 95% of AI pilot programs are failing, only 29% of executives can even reliably measure their return on investment. Think about that for a moment. We're talking about hundreds of billions of dollars being poured into technology that companies literally cannot properly evaluate. Goldman Sachs projects AI companies may invest over $500 billion in 2026 alone. That's not a typo. $500 billion in a single year. But here's what's really fascinating. This isn't just about technology failing to deliver. The research reveals something much deeper. Integrating AI into real businesses isn't like installing new software. It's like rewiring the electrical system of a century-old building while people are still working inside. The researchers draw a fascinating parallel to the Industrial Revolution. When early factories switched from steam power to electricity, productivity didn't immediately spike. Assembly lines had to be completely reconfigured, workflows redesigned, entire workforces retrained. The same transformation is happening now, but companies expected instant results. Meanwhile, there's a concentration risk developing that should terrify anyone watching the stock market. Major U.S. tech firms are allocating up to 60% of their operating cash flow directly into AI infrastructure. Since these companies represent about 35% of the S&P 500's total market cap, global indices have become exceptionally vulnerable to any AI slowdown. But here's the most important shift. The industry is finally asking the right question. Instead of what can AI do, which led to endless speculation about AGI, companies are now asking how well can AI perform, at what specific cost, and for whom. A 2026 State of AI report found that 42% of enterprises now prioritize optimizing existing AI workflows over chasing speculative new capabilities. And then there's the physical reality that nobody saw coming. AI power demand is projected to grow more than 30-fold by 2035, from 4 gigawatts to 123 gigawatts in the United States alone. To put that in perspective, a single AI data center campus now requires between 100 and 500 megawatts of constant power. That's equivalent to a small city's entire electricity consumption. Here's the problem. Data centers can be built in 1 to 2 years, but grid upgrades take 7 years or more due to permitting restrictions and supply chain issues. 72% of utility executives now identify power and grid capacity as an extreme challenge. We're seeing proposed 5-gigawatt AI campuses that exceed the capacity of the largest nuclear plants in America. The industry's response has been radical, a massive pivot to nuclear power. AWS has committed $20 billion to small modular reactors in Pennsylvania. These aren't just partnerships, they're building AI infrastructure directly adjacent to nuclear facilities to bypass grid congestion entirely. It's a tacit admission that the AGI dream simply cannot be supported by conventional electrical infrastructure. Now let's talk about the legal earthquake that nobody in Silicon Valley saw coming. The foundational premise of early generative AI was breathtakingly simple. Scrape everything on the internet, train on it, commercialize it, and worry about permission later. In 2026, this strategy has completely collapsed. Here's why this matters so much. During major lawsuit discovery phases, technical evidence has proven that AI models don't just learn patterns from data. They memorize and reproduce copyrighted works verbatim. This phenomenon, called regurgitation, has fundamentally undermined the traditional fair use defense that AI developers relied on. The New York Times, Chicago Tribune, and media organizations worldwide are winning landmark cases by demonstrating what they call massive free-riding. AI bots systematically bypassing paywalls, crawling proprietary journalism, and designing products that encourage users to skip the original sources entirely. But rather than killing innovation, this legal pressure has created something unprecedented, a massive licensing economy. News Corp executed a deal with Meta valued at $50 million annually. OpenAI signed agreements reportedly worth over $250 million over 5 years. We're seeing usage-based agreements where compensation is tied directly to how often AI models reference specific content. This licensing economy definitively ends the era of infinite free data. But even if legal hurdles could be bypassed, the industry is hitting what researchers call the data wall. By mid-2025, analyses of over 900,000 web pages showed that 74% contained AI-generated content, leaving only about 26% as purely human-authored text. We're essentially running out of high-quality human knowledge to train on. The industry's response has been synthetic data, artificially generated datasets. But here's the problem. When you train AI exclusively on its own generated data, you get what researchers call model collapse. It's like intellectual inbreeding. Meta's experiments proved that models simply cannot iteratively self-improve through self-referential generation. They need the novelty and grounding found in real human experience. Meanwhile, the European Union's AI Act has formalized these constraints with stringent copyright and transparency requirements. Developers must now disclose comprehensive training data summaries and respect machine-readable opt-out signals. The era of unconstrained data harvesting is definitively over. Now we come to the most important shift of all, the technical revolution that's reshaping AI research itself. For 5 years, the entire industry operated on one simple belief: bigger is always better. More data, more parameters, more compute power equals more intelligence. This was the era of scaling laws. But by 2026, this era has demonstrably ended. Inside the world's premier AI labs, there's now open consensus that frontier models have hit a performance ceiling. While mathematical loss curves continue decreasing with scale, the slope of actual capability improvement is drastically shrinking. In practical terms, injecting 10 times more compute no longer yields 10 times the visible gains. This realization triggered the most important technical pivot in AI history. Instead of making models bigger during training, researchers are now making them think longer during use. This approach, called inference time scaling or long thinking, allows smaller models to perform multiple iterative passes, generate internal consistency checks, and verify their reasoning step by step. And then came DeepSeek, the event that changed everything. This Chinese AI lab triggered a historic market shockwave, erasing over $500 billion from NVIDIA's market cap in a single day. How? By proving that top-tier reasoning capabilities could emerge through efficient architectural design, not brute force compute. DeepSeek achieved near-perfect 97.3% on complex mathematics benchmarks for approximately $5.9 million, an order of magnitude lower than the hundreds of millions spent by Western competitors. They did this while battling severe hardware constraints, using Huawei chips with frequent crashes and memory errors. It was algorithmic brilliance defeating raw computational power. This breakthrough shattered a key geopolitical assumption that AI dominance was tied to having the most American-designed GPUs. DeepSeek proved that ingenuity in algorithmic design could comprehensively compensate for hardware disadvantages. Efficiency had defeated brute force. But perhaps the most humbling reality check came from humanity's last exam, a 2,500-question assessment designed by nearly 1,000 researchers to test true AI capabilities. The exam was engineered with one rule: any question that current AI systems could easily solve was immediately removed. The results were staggering. GPT 4.0 scored just 2.7%. Claude 3.5 Sonnet reached 4.1%. Even OpenAI's flagship reasoning model, o1, achieved only 8%. While advanced models perform well on conversational tasks, they collapse entirely when confronted with deep, specialized knowledge. True intellectual depth remains securely within the human domain. This has profound implications. The myth that AGI is just months away has been permanently dispelled by rigorous evaluation. The industry is now pivoting from pursuing one godlike AI to building specialized agents that excel in specific domains. So, what does all this mean? Let me give you 3 concrete takeaways that will shape how we think about AI going forward. First, AI is becoming a normal technology. Just like electricity or the internet, it's transitioning from a mystical, potentially existential force into a powerful but comprehensible utility. This means we can finally have rational conversations about costs, benefits, and realistic timelines, instead of getting caught up in science fiction scenarios. The focus has shifted from theoretical AGI alignment to immediate operational reliability. Organizations demand sovereignty, data sovereignty, model sovereignty, and operational sovereignty. They're refusing to delegate mission-critical decisions to black box algorithms they can't verify or control. AI interfaces are being redesigned to introduce deliberate friction and human confirmation for high-stakes decisions. Second, the future belongs to specialized intelligence, not general intelligence. Instead of pursuing one super-intelligent AI, we're building highly capable agents that excel in specific domains. Think less artificial general intelligence and more artificial specialized excellence. This shift toward agentic AI systems is already transforming industries from healthcare to finance to manufacturing. Third, efficiency has definitively defeated brute force as the path forward. DeepSeek proved that smart architectural choices matter more than massive compute budgets. This levels the playing field globally and suggests that the next wave of breakthroughs will come from algorithmic innovation, not just throwing more money at bigger models. The shift from pre-training scale to inference time computing or long thinking represents a fundamental change in how we approach machine intelligence. Instead of building larger models, we're building smarter ones that can reason through problems step by step. This is more aligned with how human intelligence actually works. There's also a massive infrastructure transformation happening that extends far beyond software. The AI revolution is forcing a rebuild of our entire energy system. Tech companies are investing billions in small modular reactors, optical interconnects, and next-generation cooling systems. This isn't just a digital transformation, it's a physical one. Here's my final thought. The cooling of AGI hype isn't a retreat, it's a maturation. We're finally building AI systems that solve real problems for real people, instead of chasing impossible dreams of digital godhood. The industry is growing up, getting serious, and focusing on what actually works. The transition from evangelism to rigorous evaluation represents a healthy skepticism that will ultimately make AI more useful and trustworthy. Companies are demanding measurable returns, governments are requiring transparency, and researchers are building better evaluation frameworks. 2026 will be remembered not as the year AI disappointed us, but as the year AI became genuinely useful. The hype has subsided, but the foundational build-out of the AI era has just begun. And honestly, that's way more exciting than any science fiction scenario about super-intelligent overlords. We're entering an era where AI will be judged not by how closely it resembles human intelligence, but by how effectively it augments human capability. The post-hype paradigm is ultimately about finding sustainable, ethical, and practical ways to integrate artificial intelligence into the fabric of society. That's our deep dive into the AI reality check of 2026. If this analysis changed how you think about AI's future, I'd love to hear from you. Share this episode with someone who needs to understand what's really happening beyond the headlines. And remember, in a world of artificial intelligence, human curiosity and critical thinking have never been more valuable. I'm Will, this has been Mindcast, and I'll see you next time when we explore the technologies that are actually changing the world. Until then, stay curious, stay skeptical, and keep asking the hard questions.